Equations of lines, all forms. Drawing graphs. Sketch the graph of each line and label it. Put A, B, C, D on the first grid. Okay, so 4 things to graph. Let's see if we can, we get it all in here. So, A in purple. Y equals negative x plus 7. This is slope-intercept form, so you find the y-intercept, which is 7. The slope is negative 1. It says go down 1, right 1. So we're just moving on this basic little diagonal here, right? Down 1, right 1, all the way. And you can also go up 1, left 1. So negative slopes go down to the right. They also go up to the left. Join that with a line. Arrows on the ends. Don't say you haven't been told. And there we go. We're graphed. That is A. B. Y equals 1/5 x plus 0. This is also in slope-intercept form. So the intercept being 0 and 1/5 says go up 1, right 5. Go up 1, right 5. Also says go down 1, left 5. So remember, a positive slope is either a positive over a positive or a negative over a negative. And then we've got this slope of 1/5, which we know from before is not very steep. And there's B. C. Y plus 5 equals 0, or y equals negative 5. Y equals negative 5, since there is no slope, right? It just says the y values are always negative 5. This is a horizontal line. C, right? You can also think of this as y is equal to 0x minus 5, so no slope, right? Or horizontal line, slope of 0. It shouldn't say no slope, slope of 0. And in green, x equals negative 3. We have to recognize this is a vertical line. And it says that all of your x values are negative 3. It also says you can't draw a vertical line very well. And I'm about to run out of tablet. And arrows on both ends. And there's your vertical line, or x equals negative 3. So these are done by slope-intercept, slope-intercept, knowing that this is a horizontal line, which is of the form y equals, and knowing this is a vertical line of the form x equals. And this could have been written x plus 3 is equal to 0 as a general form. This is also a general form. And these guys are slope-intercept form. So let's head back. Moving down and over. E. Y minus 5 is negative 2 bracket x plus 3. This is in point slope form. So to graph this is not a graphable form, right? Well, yeah, I guess you could sort of, you could pull the point off of there, right? The point would be negative 3, and it's y minus y1, so 5. So we could do that with a slope of negative 2, or we can go into slope y-intercept form, which would probably be what I prefer. Negative 2x, add 5, be minus 1. So my preference is probably to take this directly into slope y-intercept form. And this, oh wait, let's use blue. So you do have those two choices. And the slope of negative 2, remember, is negative 2 over 1 or 2 over negative 1. So this says go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Or this says go up 2, left 1, up 2, left 1. And just keep going and going. And then we can draw this line. And does it go through the point negative 3, 5? Negative 3, 5, yes it does. So we could have, from the point slope form, picked out the point that we were using. Remember, point slope form looks like this. Y minus y1 is equal to m, x minus x1. So whatever follows a minus sign, in this case it would be x minus negative 3 is your x value, and y minus 5. So y1 is equal to 5, and your slope is negative 2. Or convert to slope y-intercept form. Draw the line. Arrows on both ends. And we're done. And lastly, 3x minus 4y minus 8 equals 0 using slope and y-intercept. So from a general form, sometimes our strategy is to, and I can go back to this purple, sometimes our strategy is to go into slope-intercept form. Sometimes our strategy is to use intercepts themselves. All right, so this is negative, so I'm going to move it over to the right side, 4y. And then I'm just going to write this side. This side stayed the same, 3x minus 8. So 4y is equal to 3x minus 8. Y is equal to 3/4 x minus 2. Okay, minus 2, there's your y-intercept. 3/4, go up 3. 1, 2, 3. Right 4. Go up 3. Right 4. Go down 3. 1, 2, 3. Go left 4. Go down 3. 1, 2, 3. 1, 2, 3, 4. And draw the line. You can use a ruler, use the edge of your calculator case. You'll get a much straighter line. Make sure you're showing these points so that if your line is a little off like this for some reason, that I can see the points that you used to graph the line. There, clean the line up a bit, but you have the idea. Red. 2x minus 6y minus 18, again by converting into slope y-intercept form. See, in this case, we would know that our intercepts, if that's 0, then this has to be 9, because 2 times 9 minus 18 would give you 0. So we do have the room to do that. But generally speaking, it's easier to go into slope y-intercept form. So this time, again, so let's move that over. 6y is equal to, this stays the same, so it's 2x, and because I've circled that, I can't read it anymore. 2x minus 18 divide 2/6x minus 3, 1/3 x minus 3. So we can graph that, minus 3. 1/3 x is go up 1, right 3, up 1, right 3, up 1, right 3, and go down 1, left 3. So up to the right or down to the left. Down 1, left 3. These points should all be on a straight line. I need to get on the tablet where I can draw this. And arrows on both ends, indicating that the line goes on forever. And oh, that's G. This is F. This is E. And we're ready to move. Writing equations. So what if we have a line and we have to write equations? Determine the equation of each line in slope y-intercept form. Determine, yeah, that's a pretty strong word. I'm almost going to say state, because what's there to determine? So we have a y-intercept of negative 3, and you choose a point. So follow the line from here until you find an intersection point. Where does it intersect? And it looks like 1, 2, 1. So the slope is 2 over 1. So the equation is y is equal to 2x minus 3. Okay. Now, if you have time, you could verify this, because you can see that this is the point 4, 5. So if I plug that in here, I should get a true statement. Let's move down a bit. And true statement, right? So we do have the correct equation. And on this one, I want SlopeYIntercept form, but I don't know what that is. It looks like a half, but maybe it's not. But I have a point here, and I have a point here. So 1, 2, 3, 4, 5, 1, 2. So the slope is 5 over 2. And I have a point. Let's use the positive point. So I have the point 1, 2. So I'm going to use point slope form. Y minus y1 is equal to mx minus x1. Y minus, what did I say the point was? 1, 2. So y minus 2, right? Formula, substitution. Okay, we know the slope is 5 over 2. X minus 1. So we've substituted in all the values, right? x1, y1 is a point on the line, and m is the slope. We calculated the slope, or we counted the slope out. So in this one, all right, hang on. Determine really does enter into this, okay? Because this one you can't just work. This one you can state. Y minus 2 is 5 halves x minus 5 halves. 2 is 4 halves, right? And I'm going to add 4 halves. So y is equal to 5 halves x. Add 4 halves to this gives you minus 1 half. And what it looked like is what it really was. It really was minus 1 half. But that's hard to tell, right? So we do have a mathematical method to calculate this, and now we can say, yes, it really is 5 halves x minus 1 half. And again, you could just try substituting a point in to see if that were in fact true, but that's something I would wait till the end of a test to do. What are we doing? Determine the equation of each line in SlopeYIntercept form. With an x-intercept of 4, meaning that it goes through the point 4, 0 and parallel to the y-axis. Well, this is the y-axis. And so parallel to the y-axis is really just going to be, it's going to be the y-axis. Okay, so parallel to the y-axis, that was the x-axis. So here we go, parallel to the y-axis, there's the y-axis, and these lines are parallel. So the equation is x equals 4, but it wants general form. General form, x minus 4 is equal to 0. So we need to pay attention to, in this case, changing to general form. Passing through -4, 5, and -10, -3 in general form. All right, so the first step, in order to find the equation of any line, you need the line's slope. So here's the slope formula. So, -3 minus 5 over x2, -10, minus -4, so make that plus 4. That's -8 over -6. So reduce and change to positive 4/3. One thing that we could do is -4, 5. That's about there. -10, -3. That's down there. And we can see that, yes, we should be getting a positive slope, so that matches up. Now that we have a slope, we don't have the intercept, so we're going to go to point slope form. So we're going to use this formula, right? You'll be given it. We now know the slope. We choose one of these points. Now, seeing as everything's minus, right, let's choose this point. That'll make things positive. So we'll get y plus 3, right? Y minus -3 is equal to 4/3 x plus 10. I want general form, so I need to get rid of this denominator. So let's, what do I want to do? Let's multiply through everything by 3. So 3y plus 9 is equal to 4 times x plus 10. Now we expand. 3y plus 9 equals 4x plus 40. General form, we need a positive x value. So 4x, we're going to subtract 3y minus 3y. We're going to subtract 9 from both sides, plus 31 equals 0. Alternatively, you could have expanded, so 4/3 x plus 40 over 3. You could have said this is 9 over 3 and gone y equals 4/3 x plus 31 over 3. So in other words, go into slope y-intercept form, then multiply through, and then move over the y. Either way, giving you the answer. So a lot depends on what it is you're doing in between, whether you need to or want to do that, your choice. Passing through negative 4, 5 and perpendicular to this, and the answer given in slope point form. And this will be the point, I guess. So perpendicular to this, what does that mean? Well, we need the slope of this. So let's move over. So we get 5y, moving that over, is equal to 2x minus 18. So y is equal to 2/5 x minus 18/5. The slope perpendicular will be negative 5/2, the negative reciprocal of 2/5, which is negative 5/2. So I need a line in point slope form, so that's the equation. And we're going to substitute in, and this is the slope it needs, negative 5/2. And we're done. This is a slope point form having a slope perpendicular to this line, so we had to calculate the slope of the given line and then calculate the slope of a line that's perpendicular to it. And then substitute that in, right? Math, formula, substitution, and here's your answer in slope point form. And we're done.